big. Oh, look at that.
Uh-oh.
It works. Okay. So do you understand the difference between a series and a parallel circuit?
The series is one line, parallel diverges. Pretty much. So if
So
like each switch controls the entire line.
can you,
So
so
that one.
can you tell me why this bulb is brighter than those bulbs?
Honestly, no. Why is it black?
Has to do with voltage and resistance. So where's Mr. Kelsey? Ah, this was an opportunity to teach him something. All right. So if we look at this, we're gonna go to this bulb right here. It's going to tell us that we're getting 27 volts at that bulb.
Okay.
All right. And if we look at this one, we're probably getting close to the same because they're main the same.
Oh, is it because the resistance is increasing?
No. Actually, there's lower resistance, so this is 27 volts too. All right. So then let's look how many volts this guy is getting. That's almost 70. This guy's being a voltage hog.
Yeah.
Okay, so if you hand me that bulb over there, all right, so what you'll see is if I switch this to resistance, this guy's got 25 ohms of resistance. Now, if we take this guy out and we look at him, yeah, he's got lower resistance, 22. So the the higher the resistance, the more voltage that device is going to take to try to power itself up. The lower the resistance, the less voltage that there's going to be available, especially in a series circuit. That's why we run lights in parallel circuits, because we get the same voltage to every light, we get the same brightness out of every light.
Okay.
You know, but plus these are also different wattages, and but the key here is to understand that.
So this is lower resistance. That's why it's brighter.
So, but if you look at this, that was 27, about 27. This was about 27. That's like 54. And this guy was like almost 70.
Yeah.
So that's like 124,
Jeez.
give or take a volt or two. So let's look at that. Let's go back over here to voltage. Let's look at what our incoming voltage is. Our incoming voltage is 122. So if we actually added all the decimals and everything up, this whole circuit is dividing 122 between these three lights.
Okay.
I watched it. It was like, ah! Like one of those bounty commercials. It'll be all right. It'll be all right. All right, so, you know, but now in a series circuit, one nice thing about a series circuit, if there's a problem, any one thing can shut the whole circuit off. So, for instance, you know, in a normal situation, a circuit we might use this in would be a heating circuit where these were all heating elements. These were safety switches, and they were in different parts of the unit. And as a area of the unit got too hot, one of the safety switches would shut it off.
Okay.
you know, and then once it cooled down a little bit, safety switch would pop back into place and everything would come back on.
Okay.
But if the safety switch has to reset itself more than 3 times, then it requires a manual reset a lot of times because it's saying, hey, I've gotten too hot 3 times too quickly. I need somebody to look at me because something's going wrong. You know?
So for series, it'd be for safety.
Yeah. Well, the normal situation we use series circuits in is safety.
Yeah.
We'll put a safety in series with something that we want to protect.
Okay.
And we want to protect motors, so all our control systems, that we put those in series with the motor, so if something's happening, the motor's getting too hot, it's getting too many amps, you know, if it's overamping or anything like that, the safety is supposed to shut it off so we don't burn up the motor. Because, you know, it's expensive to replace a motor sometimes.
Yeah.
All right. Any other questions?
No, I at least now I know how this works.
Yeah,
At least refresher.
absolutely. All right.